I'm Kannan here. Pleasure to welcome you all to the next episode of our Yugabyte Friday Tech Talks series. And today I have with me Neeraj Kumar. He is the Director of Engineering at Yugabyte and leads the DB ecosystem team. He's based out of Pune, India. And really happy to welcome him for this talk. So Neeraj, over to you. Thank you.
Hey, thanks, Kannan, for the introduction. Hello, everyone. Thanks for joining this session on smart drivers. This, as you know, YugabyteDB provides two APIs, YSQL and YCQL. So we have drivers for both. So today we are going to specifically talk about the YSQL smart drivers. So with that, so this will be the agenda for today. We'll try to understand what smart drivers are, what are the features we are talking about, and then we'll try to understand these, this concept through some use cases. Post that, we'll try to walk through some code snippets. These won't be like production quality code, but some sort of idea about how to use the drivers. And then towards the end, we will try to do a couple of demos demonstrating the smart driver features. So the idea is to make the applications ultimately smart, right? So if the applications are using our drivers, then they should take the advantage of the distributed nature of the database, and they should connect with the system, the YugabyteDB cluster, in the most optimal way. So to understand that, let us try to quickly look at the popular deployment topologies with YugabyteDB. Especially like these topologies are popular because of fault tolerance. YugabyteDB is a distributed SQL database. We have multiple servers which constitute the database, and the way users prefer to keep the database is like they want to have servers in different availability zones, or they can have like a single cloud, but multiple regions they want to have, so that servers are there spread across regions, so that if some region goes down, still the cluster is operational. And then probably so some user might want some fault tolerance for the cloud as well, so they may configure the cluster across cloud. So we'll take the second one for the illustration of the feature. So let me go into some of the application requirements. So let's say we have a cluster here, which has it's in AWS cloud, and let's say it is in 3 regions, 2 West Coast regions of the United States, US West 1 and US West 2, and the third is in the US East area. Now there are several applications who wants to talk to this database. Let's say the application 1 comes, since the PostgreSQL JDBC driver, we are going to talk about the YSQL driver is about the JDBC driver. And Postgres drivers, all the Postgres drivers work out of the box with YugabyteDB because we are PostgreSQL compatible. So today the users are mostly using the PostgreSQL upstream drivers to connect to YugabyteDB. So let's say the first application comes, and it says that, I am not a very critical application. I need to just connect to any of the servers available. But I need to basically distribute the load across all the servers, so it can connect to any of the servers. Then you may have another server application. That application say, okay, I am geography closer to, let's say, US East 1. I need to just connect to servers because he's like latency is concerned. So he wants to connect to a nearer server. So he just wants to connect to the servers which belong to the US East 1 region. It could be another app which says that, okay, I have 2 kinds of requirements. I need to have one pool which connects to, let's say, US West 1. And let's say I just want to do reads on those. And for writes, I just want to connect to US East 1. So these are just to give you some idea, why different applications may need to configure themselves differently to talk to the YugabyteDB servers. So what do users do in such scenario today? So today, what the users are doing is that they are introducing are basically configuring and deploying some load balancers between the applications and the clusters. They may configure one or more load balancers depending on the need. So there could be one load balancer which just looks after the US West region servers. One could be like can have all the servers behind it. So yeah, depending on your use case, you can have one or more load balancers. So clearly, like there are, I shouldn't say issues. Load balancers are very popular products and they solve a lot of beautiful use cases. But still, there are, if we can avoid that, I think it'll be good. Because after all, it's an extra component. You need to maintain it, manage it. There's a certain cost associated with it. So if we can kind of do away with load balancers, I think everyone will prefer that. So, and not only the cost part or the maintenance part, it's also like it might not suffice all the needs of the applications, and it will be very difficult for to cater to all the applications needs, etc. So giving the control into the application itself gives much more flexibility to the application. So what we are saying is that let's bring this capability of connecting to any of the servers to the application itself. Let the application decide to which all servers or subset of servers they want to connect to. So there's just a diagram which shows that without load balancers, this can be achieved by making the drivers smart. So what are the smart drivers? Let's get into that. So first of all, we are not developing these drivers from the scratch. As mentioned, we are PostgreSQL-Wire compatible. So any drivers which work with PostgreSQL work with us. So what we are doing is that we are forking the upstream drivers and we are adding some smart features into those. So currently the two smart features are basically two different flavors of inbuilt load balancing in the driver. So one, we call it as cluster-aware load balancer or load balancing, uniform load balancing, wherein you can configure the driver and therefore the application such that if they create n connections, the driver will try to uniformly divide all the connections across all the available servers. Now, the second flavor of the load balancer is such that if you don't want to like uniformly distribute the load, but you want to just connect to a subset of the servers available. Let's say, as I was saying earlier, if you want to be affinitized to, let's say, a couple of servers which are just in the US East region, so you can direct or configure the driver to just have connections on those servers, and the connections will be uniformly load balanced only on the subset of those servers. So
Neeraj, Neeraj, perhaps one question here. So we're talking about smart drivers in the context of our SQL API. Can you give some context about what happens in the NoSQL, like the Cassandra API of Yugabyte, YCQL API? Yeah. Is there a similar notion there?
Yeah, excellent question, Kannan. So essentially, the YCQL side is in some sense already very smart. So the way we are compatible with PostgreSQL, in the same way for the YCQL side, we are completely compatible with the Cassandra drivers or Cassandra. So Cassandra itself is a distributed database, unlike PostgreSQL, database, which is like mostly a single node database. So these Cassandra drivers themselves are pretty smart. They have a lot of features. You can set policies in them to configure, make the application, connect to a local data center. You can define policies for certain consistency level, etc. So those things are, already there in YCQL drivers. In some sense, they are already smart. Having said that, we have made certain changes in them as well to suit the YugabyteDB cluster. But essentially, they are by default smart, is what my short answer would be.
Thank you.
Yeah. So how we have changed the database is essentially the driver is like we have changed the URL from JDBC PostgreSQL to JDBC YugabyteDB. The primary motive was to make both the PostgreSQL driver as well as the Yugabyte driver coexist in the same class path. If you were have kept the same connection URL, it would have been not possible. This is a suggestion which came from the Postgres community, and we accepted it. It was a nice suggestion. And similarly, the driver, etc., got renamed. So essentially, when you configure the driver, you provide a single endpoint. Your cluster may be having multiple servers, but you provide a single endpoint to the driver. The driver connects to the cluster. It should be a healthy endpoint to start with. If it is not, you can give more endpoints so that one of the healthy servers, if it is up, it will just connect to that and it will discover the entire cluster. It will know about all the nodes in the cluster. And then not only discovers for the first time, it also continuously refreshes the cluster with the latest state of the cluster. Like it may be possible that later you add more nodes to scale up the cluster, or you bring down in less traffic time and you have less number of nodes. So these things are automatically refreshed by the driver itself. So this feature, what is the current state of the smart drivers today, right? I mean, as I said, that we have forked the repository, the upstream PG-JDBC repository, and we have the forked version in our Yugabyte GitHub organization. It's currently implemented only for the Java JDBC driver. Of course, the jar is in the Maven central coordinate is mentioned over there. You can include this in your pom.xml and you are up and running with the driver. And as we are speaking, we are introducing this feature in the Go driver, the C# and the Python version of the drivers for the smart features. And this should be available in less than a month, I would like to say that. And the C++ drivers is also being worked on, even they should be available pretty soon. But a more future, scope is also there. We want to take it to the next level, wherein we want to add more features like data aware, data location aware query routing or DML routing. Like the driver figures out the layout of the data in the cluster, and it figures out automatically, like for a particular insert or update or delete, like the right operations, which will be the best server, where is the leader tablet exists, and try to directly connect to that instead of a sticky one connection to a particular server scenario. Similarly, for queries, it should know that, okay, whether I can do follower reads or I can go to the secondary tablet and still, query the data. I'm not so performance sensitive or correctness sensitive. So all those capabilities also we want to add in the future.
So Neeraj, presumably, okay, you are going to get to the code snippets. Yeah, my question was, presumably the bulk of the application program does not have to change, like how you prepare a statement, bind or execute it. The initialization phase is where there are going to be changes to leverage the smart driver.
Yes. So essentially the idea is that if you are having a JDBC application today, all you need to change is the connection URL, nothing else. So instead of, so the Postgres URL is JDBC:PostgreSQL. All you need to do is you need to go and change the URL to JDBC:YugabyteDB. And in this orange, the orange color I have used to just highlight the new properties which I have added. So the property is load balance equal to true. So all you need to do is go and do this in your application. And then and of course, if you are using the completely qualified class name, there you need to kind of change it, because we are repackaging the classes, because we want to make the PostgreSQL classes coexist, or the driver coexist with the Yugabyte driver. But as long as the imports are there and you are not using the fully qualified names, nothing else needs to change. So this is a code snippet which signifies that, once you have set the URL, and let's say you are trying to create n connections. So in a loop, let's say you call driver manager.getConnection JDBC API and you start creating connections. So after the connections are created, what will happen is that in the first case, all the connections will be uniformly distributed across all the servers. And in the second case, which is about topology aware, it will go and get uniformly distributed across these two locations, which is Cloud 1, Region 1, Zone 1, and Cloud 2, Region 2, Zone 2. If there is some Region 3 or other cloud, then the connections won't go there. Similarly, if you want to use the YB cluster aware data source, this is the data source which we have added. We have extended the Postgres simple data source, and this data source is by default uses load balancing. All you need to do is set up create the object YB cluster aware data source. You need to set the host name, the username, password, and you start creating connections. If you create like n connections, that will be equally distributed across all the servers. And if you want topology aware, you just call this set topology APIs, provide the topology keys, and then it will do the topology aware load balancing. Similarly, you can also configure the pool with the YB cluster aware data source. You need to set the pool first, configure it properly, then you create a Hikari config. This is an example with the Hikari config, but the Tomcat pool, etc., will also work with this data source. And you basically, after creating the the connection pool a config, you create the Hikari data source with this config, and then when you try to create connection out of this, it will be uniformly distributed across all the servers or the qualified servers, as the case may be. So with that,
Neeraj, a few questions coming in. So one was when we have the Python version ready to go of the smart driver, would it be pip installable?
Yes, it will be pip installable.
Okay. And then another question is on multi-region deployments. And if you have a multi-region cluster, the question is like, what happens if you don't specify the topology keys parameter?
So if you go for a load balance equal to true and don't specify the topology aware, then it will be the first case wherein it will try to uniformly balance across all the servers.
Yeah, all the servers in all the regions. Yeah.
All the regions. Yeah.
Makes sense. And yeah, maybe there's one more question, like, is this compatible with the PG bouncer connection pooler?
It should be. It should be because it just needs an endpoint, and we haven't tested it very honestly, but it should be because it can talk to a Postgres endpoint, and PG bouncer is nothing but a Postgres endpoint.
Cool.
Shall I move ahead, Kannan?
Yeah.
Yeah. So there are a couple of demos, actually 3 demos, which I want to quickly do and show to you guys. So the first demo, in this particular demo, I have exactly replicated the case which I was talking about earlier. We have created a cluster which is spread across 3 regions. 2 regions are in the US West side, US West 1 and US West 2, and 1 in the East. And we have 1 server each in each of those regions. So in the first app, what we'll try to do is we'll try to just create 10 connections and see how it load balances. So the first app is about uniform load balancing. And once that runs, we'll run the second app, which will demonstrate the topology aware. The second demo is more about how the driver, the smart driver, refreshes its information in the scenario when the cluster size is changing. Is it able to keep up with increased number of nodes, or less number of nodes if some node has gone down, etc. So let me go to the demo. So first of all, so this is the cluster which I've already created. If you see the diagram here, these are the 3 regions in which the clusters are there, as in the nodes are there, and these are the nodes. Okay. So just a small implement. I mean, don't want to go into the details of the implementation, but there's a small, just detail about the internal implementation. We have added this YB_servers function. It's more like a virtual table function which we have added, and you can run it like a normal SQL. So here I have created that cluster, and I have using the YCQL shell, I got connected to the server which is running there. And by firing this query, I get to know the details of all the servers, their placements, where they are located, etc. So essentially, in short, this is the magic potion here, in the sense all the drivers, they call this thing regularly or at some required time, and they get to know about the latest state of the cluster. And this is what they use to maintain balance from the app in which they are creating connections. So I've written this. Let me actually take you through the example quickly. It is the same example which was there in the deck. just is taking some command line argument to figure out which host it has to connect to and the number of connections which it has to create. And then in a loop, it is just trying to create those number of connections, and then we'll see whether it is creating the equal number of connections or not. So this example is already compiled and should run. Let me check. Okay, so this is a uniform load balance using URI properties, like the properties mentioned in the URI. And this is the one of the endpoints, one of the servers. So let's run this. So it's creating 10 connections using endpoint. It says using endpoint, and it is just creating some connections, those 10 connections. Yeah, so you see that there are three, the 10 cannot be equally divided. So 3, 4, and 3 connections got created. Let me quickly go to the next demo here. Here we are running the topology-aware load balancing. And here we are saying that I just want to connect to the West regions, West 1 and West 2. So again, it is trying to create 10 connections.
So Neeraj, somebody said they cannot see the very top of your screen. Maybe how many lines? I'm not sure how many lines they're not able to see. Maybe some kind of LinkedIn truncation, like the trunk.
I don't know. Is it better now?
Yeah, I'm able to see it though, so not sure.
Okay. So here we chose actually 2 regions, and all the 10 connections actually the servers which are in those 2 regions, it got equally divided, and the East region server was not touched at all. So this is an example of the topology aware. So these are like similar examples, but it's just demonstrating the subset scenario over here. The second, I'll have to, 1 second. Because I'll have to run like this, I guess. Is it visible, Kannan?
Yes, it is.
Okay. So this is one of the packaged example, as in in the repository itself, we have created the examples directory, and there are a couple of examples which are there. The source code is there, and we have written this utility script, which basically wraps. Let me show you actually. So this script basically brings up server, brings down servers, and at the same time runs a Java application. And this script basically coordinates between these actions and the running of the Java application. So here I'll be running a uniform load balance example, and I'll try to show what happens when servers come up and down. So here I'm starting the script in it is just running on one machine, in my local machine, and here let me start it. So I don't know why it went down. Maybe. So here, if it is visible, you can see that it is asking whether uniform case you want to do or the topology. Let's do the uniform one. So it is creating a 3-node cluster. It'll take a bit of time because it's creating a cluster, but shouldn't take much time. Yeah, and it has started the Java app, which does the uniform load balancing, and it is trying to create 6 connections. So we have 3 servers, and 6 connections are being tried to be created. Here we are doing some, SQL queries, creating some tables, running some queries, just to check the sanity of the cluster, that everything is running fine or not. And then we are checking that, so this is all 3 local nodes were there. So it has created 6 connections, 2 each to all 3 servers. Then let's add one more node. So we are adding one more node. And then after adding the one more node, we are creating 7 new more connections. So now even the 4th node got some connections. Actually, it again tried to divide the 7 plus 6, 13 connections equally among all the servers. And here the server number 4 got 4 connections, and the rest had some had like new connections and some are old connections. Then let's say I'm stopping one of the nodes out of these 4. So the node number 3 is stopped. The driver is giving some warning message because it could not connect to server 3, and therefore it refreshed its server list. And so therefore all the connections which was there on 3 got lost, and of course nothing is there. But the new connections were further created on the remaining servers. That's why the number of connections increased on the existing servers. So with this, I think, I hope probably you guys would have understood and the screen was visible. So okay, thanks. So with this, Karan, I think the presentation is over. I just wanted to say that we have this Slack channel where we have created this YFTT channel. If you have further questions, please contact us there. You can also ping me. My Slack ID will be Neeraj YB. You can easily find me on our Yugabyte Slack. And please don't forget to star our product here, YugabyteDB. So thanks a lot. And thanks again for joining the session.
Yeah, Neeraj, there are a few questions. Maybe we can take it. I just wanted to also add that just to summarize before going into the questions, that firstly, like the applicability of smart drivers is immense even in a single region setup, as you have seen. That's what Neeraj showed with the uniform load balancing option, that automatically being able to discover new nodes joining the cluster, keeping the connections balanced, all of that without having to manage a load balancer on HA proxy layer is really powerful as apps want to leverage distributed SQL databases, right? Now, the second aspect Neeraj talked about is multi-region deployments and how you can guide your applications to connect to specific regions. But one natural question you may have there is, hey, why do I want to control, like, which region am I talking to? Does it affect my correctness property? Am I going to get the latest answer if I talk to region A versus region B? So there might be more questions that on your mind. And some of the subsequent talks on our Friday Tech Talks are going to cover those aspects of multi-region deployments, the consistency and performance trade-offs of various multi-region deployments, whether you're choosing like read replicas or trying to do read from followers instead of reading from leaders, right? So stay tuned for those talks. So with that, let me ask a couple of questions. Let me ask them to you that I'm seeing on the channel, Neeraj. So one of the questions is a single driver connection thread safe? Meaning, can I share the connection among several threads? So do you know if the, sorry, go ahead.
That cannot be done because we are built on the Postgres driver, and it's a very sticky kind of thing. It is like if several threads are given the same connection and they do different things, so the state is spoiled, so you can't do that. But that is, I understand your question. It's a nice question because every connection creates a child process on the server, and it would be great if we can multiplex several logical connection over one physical connection. But right now, it's not there. Maybe sometime in future we'll do it.
And there was another question, Neeraj, about, and this is an extension of the PG bouncer question. They asked if the first time they asked was if is it compatible with the PG bouncer connection pooler. And then the second clarification they asked is, what about in transaction pooling mode? Are you familiar? I'm not familiar offhand, but if you know, Neeraj, or we could take it offline in our Slack channel, we could encourage them to post it on the Slack channel.
I know a bit about that. So there is a transaction pooling mode wherein for the entire duration of the transaction, the bouncer needs to dedicate one connection so that you don't use different connections for the same transaction. So all those things is doesn't, like the smart driver, it just connects to the PG bouncer. Now, since one physical connection is created, it is the responsibility of the bouncer to have that stickiness for the transaction. So that should work. I mean, the driver should not spoil it.
Got it. Thank you so much. And I think we are exactly at 10 a.m. Pacific. So I think we can call it a wrap. Thanks again, Neeraj, for giving this talk on smart drivers. And thanks to all those who joined the talk.